today is really the mechanics of doing that safe system assessment. So we've had 3 wonderful modules of getting everybody on the same page in terms of the principles, or at least to understand the principles and sort of get their head around some of that, and get an idea of some of the infrastructure features that improve alignment with safe system principles, understand that intricate complexity of the system and all those interacting elements, and the fact that we need all of these working together, and we should be looking at all of those. So that's been good. And now we jump into actually how do you do this assessment? How do you write that report? How do you fill these things out? And then we're going to send you off and get you to do a safe system assessment. That's going to be your assignment at the end of this module. So Kathy, I'll just let you talk about anything associated with that now. We'll talk about it at the end, but sites and things, have they been provided?
Yes, the sites are in the Module 5 folder in Schoology. So your site, your safe method work statement is in there as well. If you can have a read of that and tick that you agree to be safe when you go out on your site visit, that'll be terrific. So that's all in your Module 5 folder. A copy of the template, Word version of the template for you to mark up. Ken will run through this again at the end of the session. Your site, so have a look for your name, and your site has been located somewhere near your home office. And again, if you've got any concerns with the location, it's too far away from you, or you've moved or something, just get in touch with me and we'll see what we can arrange.
Awesome. Thanks, Kathy. And as per usual, Kathy will be monitoring the chat and the questions and feeding those to me as we go. So please pop your questions in, and we'll go from there. Kathy, just yeah, jump in anytime.
Sorry, Ken, just a quick question. We have sent you concept design, so that is correct. We're looking for you to do a safe system assessment on the concept design. So we'll run through that again towards the end of the session.
Okay. Just get myself ready here. Okay. So what we want to cover off today is firstly to point you at guidance on how to do a safe system assessment. We will certainly cover off how you do them, the mechanics of these and the like, and you've got a good grounding on those principles, but we'll point you at guidance if you do want to follow things up. We want to show you how to complete the safe system assessment matrix, which is the meat of a safe system assessment. And then show you how to write up that safe system assessment report and how to categorize any treatment ideas that you're putting into this report into primary or supporting treatments. Remember to count your wallies. That will be one of the questions at the end of this module. So we've talked about this idea of the safe system, and we've talked about there's different elements to the system and they interact. And there's lots going on there, and it's not just this sort of blinkered, siloed view of different elements, that we need to holistically consider all of these things. We all talked about the different principles of the safe system, that aspiration of no death and serious injury, the acknowledgement that people make mistakes, the shared responsibility, and the people are vulnerable. And I was just chatting to some New Zealanders earlier this morning, and they like to sort of talk about this thing, which is, you know, to work for no crashes, but plan for crashes as well, if that makes sense. So yes, we're trying to reduce the number of crashes in any way we possibly can, but also planning and managing the infrastructure so when crashes happen, the harm is minimized. We jumped into this exposure, likelihood, and severity as our way to analyze risk. And you did a whole assignment there on categorizing things into exposure, into likelihood, into severity. This exposure one is really what people have a little bit of a trouble with, I suppose. People are still getting their head around it a little bit. And really the easy way to do that is to just think about that as numbers. If we can count the number of pedestrians, the number of cyclists, the number of motorcyclists, that's going to be our exposure score. The likelihood is most of the other stuff, and the severity is around the speeds, the angles, the vulnerability of the road users, and the like. So that's that reminder, and we'll be using this again shortly. So the question in the trivia was about this 10% risk mark, and the 30, 50, 70 kilometre per hour being where things go really bad really quickly. They turn to an exponential kick up in fatality chance after this point. So what we're really trying to do is get ourselves down that side of these in terms of any collision speed, not necessarily speed limit, but it could be operating speed achieved through many different ways. This is going to help you in your assessment in terms of quantifying that severity score. So you're going to be looking back at these graphs. You're going to be looking at these different tables of information that we've provided. So 50 kilometers per hour for that 90 degree, a little bit more for those other angles, and we talked about that. Side impact with poles, somewhere probably around the 40 kilometers per hour is where it starts to get really bad really quickly. 30-ish for pedestrians and cyclists. And then there's a bit more information there as well. What we did also in module 1 is to provide you with that heat map style matrix where it can give you a bit of an idea of different crash types and the sort of severity outcomes we'd be expecting. So I encourage you to look back on that. And Kathy, we might need to actually provide that to the others that have just joined for this one, who have done the principles components in previous years in order to make sure everybody's on the same page. So, how to do a safe system assessment. Now, we do have a quiz question that may be loaded. It may not be loaded. If it's not loaded, I'll just ask it. You can type it into the Q&A. So, Kathy, do we have a quiz question there? Yes, we do.
We sure do, Ken, if you don't mind. Okay. So hopefully it's popped up on everyone's screen, but basically just want to know, what has been your involvement with safe system assessments? Is it nothing? Safe system what now? I've heard of the term, but don't know much more. I've had one done on one of my projects. I've done one, and I'm Ken Beer. I live, breathe and eat safe system assessments. So if you just pop your answer in, or if you let us know in the Q&A or the chat, you are not much, a little bit, or quite intense. And just while people are doing that, Ken, a quick question. Can we use the 90-degree data for collisions into power poles, trees, etc.?
No, so that one's its own beast, and it actually is a lower speed because the when you have a 90-degree crash between passenger vehicles, the energy is distributed across the vehicle. Whereas if you side impact into a power pole or a tree, it's all a concentrated force load. So there are some figures in there for side impact with power poles, and it's a bit lower. We're more in the 40 kilometre at that point where it really starts to kick up. So it's even a lower speed on that one.
Okay, thank you. All right, we might close that off now and just have a look at where our people are coming from.
Okay, so some people very new to this idea. Some people have heard this, and a few have had safe system assessments done on projects. So that's good. That helps me to sort of understand the level of explaining things, which is good to know. Thank you for filling that out. So the Safe System Assessment Framework is something that Austroads has developed and documented. And this is the Austroads Safe System Assessment Framework. So I suppose I'll give you a bit of the background of how this came about. So back as I was working in the Victorian Road Authority, Vic Roads, and this was around 2012 probably, maybe 2010 to 2012, and we were starting to get some traction with the idea of the safe system, and we were sort of pushing this idea out to the projects and the regions and trying to get everybody to align highly with safe system principles. And what people started saying with their infrastructure projects predominantly was things like, well, is this project safe system? Or you can't do that because it's not safe system, or these sorts of comments. And this is what happens when you get a philosophy like the safe system and you start to actually put it on the ground and implement things. And the issue there was that how do you know if something aligns well with safe system principles or not aligns well with safe system principles? You need some sort of way to score this in a sense, to assess this. There's a bit of a challenge in terms of that commentary around that it is safe system or it's not safe system, because we know that is a spectrum. There are things that align highly with safe system principles or things that don't align highly with safe system principles. So to say it, is that project safe system or not is not really a sensible question to be asking. It should say, how much does that project align with safe system principles? And it was around that time actually that I decided to step out and start a company called the company Safe System Solutions, which was completely just playing on this idea that we had a big market of people demanding to know whether they're or asking for projects that were safe system, and so the Safe System Solutions is slightly tongue-in-cheek because it should really be solutions that align highly with safe system principles, but that's not as catchy a name for a company. So Safe System Solutions it was. And what we started doing in these early days, and there was a couple of colleagues in Western Australia from Main Roads WA and some from New Zealand Transport Authority who were doing this at similar times as well, was to start to bring together a methodology where you could give a report card on a project for how well it aligns with safe system principles. Now, we called them safe system audits at the time. And we did that because we were all road safety auditors, but we wanted to give this enhanced focus on severity and enhanced wider look at all these other elements of the safe system. So not having just those infrastructure blinkers on, but just looking how that interacts with all these other elements in the system. And so we turned it a safe system audit to help people accept it. It's very much similar to the audit process, but we're giving some different outcomes. Austroads then sort of said this is a good idea and took it on and developed this project to develop a framework. Now they called it safe system assessment in order to differentiate it from a road safety audit. So people didn't just continue on doing road safety audits and just change the name, but do their exact same process. So it's called a safe system assessment. And Austroads got together and put this document out in late 2016 with some guidance on how this can be done. So we got ourselves to this point now where we can use this framework. You do need to understand those principles that we've been through. You need to understand how to categorize things into exposure, into likelihood, into severity. And we've had some practice that, and you'll continue to refine your processes there. The first thing I want to say about the assessment framework itself is that it is very scalable. It is very versatile. And you can see here that these are sort of the subheadings of this document. The objective of the assessment is the scope, the scale, what you're doing. And it can be that you do this on individual pieces of infrastructure, you know, a new roundabout being planned, or a town bypass, or you know, local area traffic management scheme, whatever it is, you can do that. But you can also use this to assess a whole, like a remote community, a whole township. You could do a program. You could assess a program if you wanted. So you've got that quite a bit of scalability in this. You first of all understand the project context. Why is this project happening? Where is it happening? What are the things going to be changing? Or if there is no project and it's just the existing conditions that you're looking at, well, you get an understanding of the land use, you know, where are the schools, what are the road users using this area, how are they using it, what are the vehicle types, this holistic sort of gathering of information. Then you do this assessment framework. And that's the meat of the assessment. That's where we're going to spend a lot of time today talking about how you actually fill out this matrix. And then you come up with some treatments, some things that you suggest to improve alignment with safe system principles. And we do some categorizing of those. So it's all documented in this document. And of course, the document is free to download from Austrad's website. But to make your life even easier, we've popped it onto your memory stick, and we've popped it into Schoology there. So it's in the resources, and you can happily grab it, download it, and have a look at it. Now, the two jurisdictions that have taken that guidance and done more work on it to get more guidance are Victoria and South Australia. And so I will, I suppose, talk about the different guidelines and some of the clarifications that have been produced in these. Now, New South Wales doesn't have any specific guidelines on safe system assessments. You do have those for road safety audits, but you haven't got there with safe system assessments at this stage. However, what I'm seeing is New South Wales was a bit sluggish to get started on the safe system assessments, and some of the other jurisdictions leapt out ahead and have been busily doing them and getting guidance and putting it into policy and making it very much part of the way operations. But New South Wales has woken up to these now, and they're starting to really ramp up in their uptake. And so we're seeing a lot of the major projects to start with having safe system assessment requirements. We're seeing it integrated into contracts out of Transport for New South Wales, contract requirements, where they're simply saying that we want a safe system assessment done at the early stages, and then road safety audits done as the design gets into detailed phases. And I really love that, because the safe system assessment is this big picture, holistic tool to shape the project. And when we're into very intricate details, like, I don't know, barrier overlap, or, you know, degrees on the flare rate of a barrier system, or these sorts of things, it lends itself a little bit better to the road safety audit process. And also the holistic nature of the safe system assessment, again, is a bit weird to be done at design stage when all the major decisions have been made. And if you're in there challenging the whole fundamentals of the project at that detailed design stage, it's not taken very well, or it's just not taken on any ideas. So I'm going to do a weird little thing here, and I'm going to start with the end product rather than sort of how you start to piece it together. And I think this might help you get this clear in your mind, because it is very confusing when you start to look at these things. But here is what you would expect as one sort of major end output that you would expect to see. There's lots of other things, but this is really becoming something that people look for in a safe system assessment. So people get their safe system assessment, they open up the first couple of pages, and they want to see this graph. They want to see the results of how their project is aligning with safe system principles. Now, I've just picked a random project here, safe system assessment that was done. And what we see here is these red bars are the existing conditions. The orange are looking at a design for a roundabout at this location. The blue is looking at a design for a set of traffic signals with a modified T-style intersection. And the grey is a modified T-style intersection, a conventional T-style intersection with traffic signals as well. In a safe system assessment, there are these scores given for a whole lot of crash types: run-off road, head-on, intersection, other, which I'll tell you about in a minute, pedestrian, cyclists, and motorcyclists. And what I can tell you about this area immediately from this is that their existing conditions, they have come up with proposals to alter the existing conditions, and the roundabout looks like it's coming in as the best alignment with safe system principles, except for cyclists. And the reason I can tell that is because the lower the score, the better. So you can almost say this is like a risk graph. The lower the risk, the better. So this is quite nice. I can immediately see a whole lot of information about where my risks lie for this proposal and these different options, which one is better and where there's still residual risk. So as I said, I've jumped to the output. Now I'm going to take you through how you would actually go about building this from different information. And then also how we come up with some recommendations to make these graphs even lower when they take on some ideas. So the first thing you do for a safe system assessment is to understand that context. And I mentioned that before. What is the context? Is this a existing site and you don't have any designs? Is it a fatal crash investigation? Is it just an existing area that people are interested in improving? Is it something where there is a desire to change it and there's some concepts and there's maybe, I don't know, there could be 5 different options on the table. We could do a roundabout, we could do traffic signals, we could do splitter islands, we could do a modified T, we could block off one of the legs. They're all on the table. So you're asking these questions. What are you going to do? Why is this happening? What is the existing environment? What is the land use? What is what road users are present? What's the vehicle composition? These questions that I've put in here are straight out of the Austroads Safe System Assessment Framework, and they're the prompt questions. And so what I do in a safe system assessment is sometimes often I'll start with a catch up, a meeting with the project team, maybe the designers, the project manager, and just go through each of these questions, have that conversation, build a picture of this project, not just simply from looking at the design, but trying to holistically understand what is going on. Sometimes, you mightn't be in that position and you might just have to have a go at filling these out yourself, or you maybe send these in to somebody who is going to fill them out. But you're trying to just build that picture. Once you've got that, you then start to go to thinking about this safe system assessment matrix. Now this is the matrix, and what we have here is 3 rows to the matrix: exposure, likelihood, and severity. So you can see why I've been banging on about those throughout the last 3 modules. They are the elements that we are going to populate these cells. Across the top here, the columns, we have the major crash types that are presenting death and serious injury to the travelling public in New South Wales. Run-off road, head-on, intersection, any crash where a pedestrian is the one that is killed or seriously injured, cyclist, motorcyclist. The other here is the opportunity to put any crash type that you have predicted or you're worried about that doesn't easily nicely fit into one of these other categories, and you would write under there what that specific one is. So it might be a railway level crossing. It might be something that you've decided is quite prevalent and is not nicely fitting into pedestrians. Maybe you've decided e-scooters. You're going, well, we're getting this new e-scooter scheme in, and we don't know how it's happening. I'm not comfortable just lumping them with pedestrians, even though the road rules might say they're a pedestrian or whatever it is. But you actually say, well, I'm actually going to use this other column for them. So you get a bit of freedom to use that as you want, and then to write what that crash type is. So these are your columns, and what we get there is a cell of the matrix for each one of these, for each crash type, and for exposure, for likelihood, and for severity. And what we're going to want to do is, in every one of these cells, is to document what factors are making us want to make the score in here higher. So what is increasing the risk and what is decreasing the risk? And I'll explain this, and I'll show you a worked example shortly, because that'll make life a lot easier. I'll pause there, Kathy, and I'll see if there's any questions that need to be dealt with now.
Could you argue that a percentage of heavy vehicles would be a severity variable?
Yes, absolutely. Yep, spot on. And we'll definitely put that as a severity influencer. You may, in some circumstances, put it as a likelihood variable if the particulars of the vehicle, and maybe its swept path or something like that, is going to make it more likely a crash happens. But a lot of the time, our roads have been set up and designed, and they're catering for that heavy vehicle. It's just when mistakes happen, the severity is way higher. So you will see in safe system assessment matrices, when people have been dot pointing out different things, that, for example, head-on, we've got speed, but they might put percentage CV high. So what you're seeing on the screen there are just a few little ideas of things that could influence it. By no means are these all of them. In fact, sometimes we see cells of the matrix dot pointed out with heaps of different points. So just a few ideas on some of the things that may influence there. So a great point. Other questions, comments?
No, I think that's it for now.
Okay. So what we're doing is we're trying to put a number in each of these cells. The number is between 0 and 4. So each cell is going to get a number. It's going to get a lot of text as well to justify that number. But let's just do one very simply here. We've got run-off road. So we're now looking at passenger vehicles running off the road. So these three are solely associated with passenger vehicles and, motorized heavy vehicles and cars, okay? These three are obviously just related with the vulnerable road users, pedestrians, cyclists, and motorcyclists. And this one, well, could be a bit anything, depending on what you do. So this is really vehicle-to-vehicle crashes or vehicle-to-infrastructure style crashes. So run-off road. We're looking here, what is the volume of traffic and maybe what is the length of the segment, but that often confuses people. So we're just going to stick to really the traffic volume to give us our driver for exposure. And you put a score in there based on your traffic volume. And the way you get to that is to use this scoring reference sheet, which is straight out of the Ostroge document. It's in Schoology. I've put it into the template report you're going to use. But let's have a look at how these scores come out, because you can see there's a score of 0, a 1, a 2, a 3, and a 4. So let's have a look at a 4, the highest score. Volumes of vehicles that might be involved in a particular crash type are very high or the road is very long. Therefore, the exposure is very high. For run-off road, head-on or other crash types, AADT is greater than 10,000 vehicles a day. For cyclists, pedestrians and motorcycle crashes, volumes are greater than 100 units per day crossing or walking along that road or the like. If we look down here, maybe at a 2, we're seeing the same thing, but the AADT, the traffic, is between 1,000 and 5,000 vehicles per day. And the pedestrians or cyclists or motorcyclists between 10 and 50 units a day. So what you do is you look on your score sheet and you've got hopefully some traffic data and you say, right, okay, I've got 4, no, let's go back to 1. See, 1 would be less than 1,000 vehicles a day and less than 10 pedestrian, cyclists, motorcyclists. So let's say we've got a road and we've got 700 vehicles a day on this road. When we get to here, we look back and we go 700, okay, that's less than 1,000, that's a 1. We come back here and we put a 1 in here. Pretty easy, pretty clear cut. In fact, exposure is a fairly easy one to do, at least if you've got traffic volumes. Now, what we tend to find a lot of the time is we are starting out a safe system assessment, say, can we please have traffic volumes, number of pedestrians, number of cyclists, number of motorcyclists, and percentage heavy vehicles. And what we get back is we get the traffic volume, we get the percentage heavy vehicles, and we get the people saying, yeah, we don't know how many pedestrians, how many cyclists, how many motorcyclists. And that's probably a bit of a window into some other challenges we have in the way we think about road users. But anyway, you don't need to be too alarmed in doing your safe system assessment. Use the data you're given and then make some judgment calls, some guesses at the others. And you'll see later why it doesn't, particularly make a major difference as long as you've got a general calibration of what sort of volumes we're talking about. So you go through and you do that with all of these. And usually if my runoff road's 1, my head-on's going to be 1, and my intersection possibly is going to be 1. It depends on side road volumes because you add up your main line and your side road volumes. And other, again, is probably going to be 1, depending on exactly what crash type we're thinking about. Pedestrians, well, this we'll have to decide what is this area, and did we get any pedestrian counts? Do we have those? They're not available. Okay, we're going to make a judgment call. Maybe this is a very rural area. It's a very low volume road, maybe servicing different farms and the like. And so there is, really no pedestrian activity apart from the occasional person wandering along there, or somebody breaking down, or maybe, somebody going for a walk or a run very occasionally. So you can put a 0.5 if you want. We try and discourage the use of decimal places, and we definitely discourage the use of anything more than a half. So if you want to go 0.173, no, we don't want to see that. We could go to a 0.5 if you want. But let's just put a 1 there for pedestrians. I'm always a little reluctant to put a 0 for pedestrians, especially because broken down vehicles, people stopping for one reason or another, and all of those sort of things. Cyclists, again, maybe we want to put a 1 there because there's occasional cyclists and motorcyclists. Well, motorcyclists, if you don't have data, tend to be about 1 to 2% of AADT on a normal road. If it's a popular motorcycle touring route, it'll be up a bit higher. But you'll get some refined data on that. And anyway, so you start to see that you're doing that. Now, the exposure one's easy, and you don't need to justify it much more than telling what you've assumed or what data you've been given. Then we get into the likelihood score. And this is the one where you're going to need to put lots and lots of dot points to justify how you arrived at your number. So let's have a look at this. And we see a number for 1 here. It is highly unlikely that a given crash type will occur. Well, that's not much information, is it? Well, let's go up a little bit and see what. Okay, up to a 3 maybe. It is likely that a given crash type will occur. Still not given much information here, are we? A 4. The likelihood of individual road user error leading to a crash is high given the infrastructure in place, e.g. high approach speeds to sharp curves, priority movement control, filtering across several opposing lanes at high speed. So what you're trying to do is build a picture of this road environment and this infrastructure, but also the people that are using it and how they're using it, and determine what you believe the likelihood of the crash is. Is it very likely? Is it really unlikely? But you need to remember that this is a relative score. Because the fact is that what we deal with in road trauma, at a collective level, when you talk about an individual, it is a very rare event to have a crash. But at a collective level, there's quite a lot of it in each region, if that makes sense. But what we need to do is then think of this at a relative level, relative to other areas of the network. And so things that would really influence, giving this high score would be these elements of the road network that relatively we know are highly conducive to influencing the likelihood of crashes. So those could be things like, a right turn across a couple of lanes of high-speed traffic where the drivers are making the calls on when they go. Could be things like sharp curves over a crest with adverse crossfall or something like that. It could be the fact that it is a hoon area. And that, you've talked to the police maybe, or the area really well, and that there's that tendency for people to go there and drive really fast and those sorts of things. You can factor that in to increasing the likelihood of crashes. So you come up with a score again, and you plonk that into your likelihood score. So I'm going to go maybe with a likelihood score here of 2. But I haven't just plonked a 2 in there. I mean, when you do this properly, I've dot pointed a whole lot of things. I've said and explained, this is what I see out there in the road that makes me want to increase this score. So I'm seeing high speed, and I'm seeing some signage, faded signs, seeing no sealed shoulders. But these are the things that I'm seeing out there that make me want to reduce this score. So I'm seeing the pavement's really good skid resistance. You know, there's a new set of chevron alignment markers, and they're all looking really great. It's well lit. Yeah, these sorts of factors. And you arrive at your score. And you do that for each one of these as well. Then we go down to severity. And again, we come back to our scoring reference sheet. And we look over here. Should a crash occur, it is highly unlikely that it will result in fatality or serious injury to any road user involved. Kinetic energies are fairly low during a crash, or the majority are effectively dissipated before reaching the road user. So what this means is that the energy is low for the road user. So, for example, if it's a passenger vehicle run off road that we're looking at, and there are barrier systems there, we know the energy is dissipated over time and it's not transferring to the human. We know if it's a pedestrian being struck, the speed is going to be the critical element to that, and that's going to really influence things. This is where you're going back and looking at those graphs that I've provided, that heat map, which actually I've calibrated to score for you in a roundabout sort of way. And so you're going to be able to get a good idea. So what we see here is that the road user exposure is fairly cut and dry, because if you've got traffic volumes, you just reference it off this and you plug the number in that it corresponds to. You might not have to make a judgment call on pedestrians and cyclists and motorcyclists if that data is not available. The likelihood score is highly subjective. And what we see there is this is where the road safety auditors tend to shine, and they've got really great understanding of what factors are influencing the likelihood of crashes here. They're looking at, is there a see-through effect? Is there masking, dynamic visual obstruction issues? Are the sight lines clear? You know, what's the horizontal and vertical geometry makeup? Is there stopping sight distance? You know, what are the signs and the line marking and you know, there's a whole raft of stuff in there, isn't it? And you're dot pointing all those out. So the auditors are really good at that, but it is somewhat subjective of how you peg that. The crash severity is quite well done by science and evidence in terms of those crash severity outcomes, but the subjective nature of it is you envisaging the crash type happening at certain speeds and angles. So that's where you have to paint this picture in your mind. And so you go through and you fill that out. And so maybe we've decided, because this is a low volume, high speed road, and there's no barriers and there's trees on, you know, lining the side of the road. When the crash happens, we know the severity is going to be bad, because we know that roadside crash into tree or power pole above about 40 or 50 kilometers per hour is highly likely to result in death or serious injury. So then we've got maybe a 4 down here. And what you do then, after you've filled out all these numbers, you've filled a whole lot of text out to justify your number, is you multiply the exposure times the likelihood times the severity. So we do 1 times 2 is 2 times 4 is 8. And we get a score down the bottom here for runoff road of 8 out of 64. It's a bit hard to write with my mouse, but you get the idea. And we do that then for head-on crashes, and we get a score out of 64. We do it for intersection, other, pedestrian, cyclists, motorcyclists, and then we add up all these scores. So you then add these. That one, and you get a final score out of 448. There you go. X over 448. If a project aligned perfectly with safe system principles, it would get a score of 0. If it's the furthest away from alignment with safe system principles, it will get a score of 448. Now, I've done hundreds of assessments now. No project has ever got 0. And some have got some fairly low numbers, but none have got 0. And the beauty of this to a degree is it acknowledges this spectrum of safe system alignment. So that's the general process we go through for the matrix. There are some questions that are asked at the end about other elements of the system, the behavior, the people, the vehicles, the post-crash care. They all may play a role in how you've arrived at these different numbers. Now, what we'll see shortly is that if you are doing a design, well, I should say, if you're doing just an existing bit of road and that's all, you're just trying to get an idea of it, you just fill the matrix out like this, and you've got your picture of risk there and your picture of alignment with safe system principles, and you can start to make some recommendations. If you've got designs on the table, then what you're going to do is you take your existing conditions, you score it in the matrix, you copy your matrix, and you create another matrix, and you adjust that matrix for your design. So we're seeing that relative change in score. And that's really, really important, because we just told you that there is subjectivity associated with part of this. And the way we are okay with subjectivity is because it's a relative assessment. The challenge you're going to have is that myself and my team may do a safe system assessment and score a project, and it'll come out with, I don't know, 200 out of 448. And then you and your team go out and do assessment of the same thing, and you get a score of 150. Now, the point being that the score is not the be all and end all. It's about what we change and how that changes things and what the recommendations are. Hopefully, the picture of risk comes out about the same in terms of where that score is being generated from. But the key message is to be consistent with your team for every part of this assessment and any designs or any alterations that are proposed. We are doing a lot of work at the moment on trying to get a consistent platform for this scoring. So hopefully that when we score at 200, your team will score at 200 as well. But we're a bit far away from that in terms of where we're sitting at the moment. But it's not actually a problem in the actual practical use of this, because we don't want people saying things like, you must do a safe system assessment and it must score less than 100. Because the project must score less than 100. Like putting out a program like that. So if the Centre for Road Safety put a funding program out like that, I would be very quickly on the phone to Joseph and Melvin and say, no, don't do that, because all it's going to generate is a whole lot of safe system assessments that come in under 100. And that's, it's not the point of it. So just say that, we need to see the graph of improvement from existing conditions to whatever you're proposing that brings the score down and that it takes on the recommendations from a safe system assessment or something like that. We could help with the words on that. So I think that hopefully you're starting to build a picture of how this works in your mind, but it's often easiest to just see one that's been done. And then the best way to learn is for you to do one yourself. And that's what we're going to get you to do at the end of this. And you'll get a lot more learnings. But I'm going to ask Kathy if any questions have popped up.
Thank you, Ken. For an intersection, is the AADT the total for both legs?
Yeah, so it's the sum of both legs. So that one got clarified. It took a while for us to get a bit of industry acceptance of it. And there's still pockets of people out there who want to see other slight mechanisms to do it. But what we've done is created 6 fact sheets for you on specific topics, just like that one, that are a bit unclear in the Austroads document and still unclear in the Victorian and South Australian guidance on where industry is sitting on a position for how to score that. So those 6 are available in Schoology, and one of those is how do you score an intersection? And it is just as I've said, the accepted way, certainly at the moment, until Austroads comes out with a new version 2.0 of this, is to add your main line and your side road volume. So this is where you may get scores at intersections that that pop out higher, because if you had a road of a AADT of 700, you've got runoff road risk it would be really 1 if you're dealing with the main road predominantly, but your side road volume maybe is 500, and so we see it goes over 1,000 when you get that intersection, and so the intersection score then shoots up to a 2. Are there other questions, Kathy?
Not a question, but Cab shared the Transport for New South Wales traffic counts website, and so I've just popped that in the Module 5 folder where the assignment is as well, just for anyone who might be needing that one. So thank you, Cab.
Yeah, that's great. For the purposes of the assignment, yeah, you could use that. I believe a lot of the assignments we've put a just fictitious AADTs, number of pedestrians, number of cyclists, number of motorcyclists, in order for you to be able to, we don't want you spending 3-4 days on this, which safe system assessments in their full, full safe system assessment can certainly take that and even more if it was a big project or an intersection, definitely a few days involved. And we don't want you to do that for your assignment. So we've just sort of gathered or put some of those numbers down there for you to make it just an exercise that you can prove to us you understand how this sort of all works. So, so good. Thanks though for doing that, Cav, and others might find that useful.
For sure. Sorry, just on that, Ken, we have put that data on everyone's site, and when you jump into Schoology, if you just view it in Schoology, you might find the data's not there, but then if you download the document, magically the data appears on the page. Just one of those fun little quirks.
Right.
But it's on there. Thanks.
Okay, so download your design, it sounds like is the go, and yeah, okay, awesome. All right, so what I'm going to do is use a bit of an example of a fairly simple safe system assessment to a degree. I'm going to, well, I'll show you this and then I'll show you the site. So this is an example of it's a fairly simple existing conditions matrix. So, there's the existing conditions. This is what's currently out there. No plans have been looked at yet. It's just what is actually out there at the moment. And you can see there's not much information around the exposure score, because it's just saying it's between 5,000 and 10,000. So this one hasn't even specified exactly what their counts were. Often people will say, it was, counts were 6,800 from 2018, which is between 5 and 10, and it's a score of 3. Other, so this one, including mid-block, rear end, and side swipe. So they've specified those as particular crashes they didn't believe were accurately or put into these other crash categories. And they've got a volume of 3 because it's between 5,000 and 10,000. And we see, well, it just happens this one's 3 across the board. Here we go, are assumed to be between 50 and 100 units per day, 3 assumed, and 1%, assumed to be 1% of AADT, and a 3. So we're seeing happens to be 3 across the board for exposure. Pretty easy. But then you see here that likelihood has these elements first. Factors that increase the likelihood, factors that decrease the likelihood. is basically they're saying factors that made me want to make that score go up and factors that made me want that score to go down. A bend, substandard radius, minimal to no shoulder, guidepost missing. Here we go. Lanes are wide, advisory speeds are in place. There's an edge line, street lighting. And so these things have been played out while they were looking at the site, and it's ended up with a score of 2.5 out of 4. Now, I dare say that this assessment was done, I mean, we like assessments done in teams, a bit like road safety auditing, and sometimes when there's dispute between the 2 and the 3, and you really can't decide, the 2.5 ends up being the answer. And so that's probably what's happened in this case. Factors that increase the severity and factors that decrease the severity. Speed's likely to be low coming out of the town, so that's going to reduce the severity, but we've got the downhill, we've got unshielded drop-off and culverts at the edge of the road, and the like, and so that's all boiled through and come out with a score of 2 there. And so that's been multiplied, the 3, the 2.5, the 2, 15 out of 64. And you can see that this increase and decrease comes in all of them, and it's all based on this crash type and likelihood and severity. We go through, we add them all up, and that is your existing conditions score, 118.5. And so for this one, for example, this was the road, and that's what happened. You went out and you looked at the existing conditions. It's an intersection. You know, it's got a give way, a hold line. It's got this downhill bit. You can see it. It's got an edge line, not much shoulder. There's some guideposts, there's some missing. The details of it aren't really too important for this one, but you would be out there looking at different bits, noticing things just the way you would in a road safety audit, but also focusing on those crash severities and the numbers, the exposure. Are you seeing lots of different people? Then after you've done that, you've made this matrix. It's quite a rich matrix. It's full of information. It's full of scores and justifying how those scores have been arrived at. You then look at, okay, so at that intersection, they're planning a roundabout is one idea, and this is the design of the roundabout. They've got another idea of a set of traffic signals, but on this sort of modified T arrangement, or a standard T intersection arrangement with a slip lane, a right turn lane. So you'll be looking at those and going, okay, well, each of those is, probably got different costs and got different environmental challenges, cultural heritage challenges. And what we're there to provide is which one aligns the best with safe system principles. And then also what can we do to every one of them, depending on which one you select, to make it even better aligned with safe system principles. So you take your existing conditions matrix that you've filled out, you've put all this information in there, you copy it, you paste it, and then you take, say, the roundabout, for example, and you fill out anything that has changed. So you cross out things that have been removed because this roundabout has come into play. You add anything that's new as a result of this roundabout, and you tend to color those differently so they stand out. And you change the score and make that colored if it's changed. So we see there that we're immediately saying, well, existing conditions, you've improved all these things, but you've created these other things, and you fill out all of this. The volumes are unlikely to change unless something is altered. A road's been closed, or I don't know, part of the project is a whole new town bypass, or that could change associated with some of that. But you fill out all this, you clearly mark things that have altered and changed. And you do that for every option. So you copy that existing conditions matrix and you do it for each of the options. And then what we're able to see is this score, total score, gets spat out. And so for this site we've been looking at, we have this existing condition score of 118.5. We have the design option number 2. Well, so these were just their names of the design options. Number 2, the roundabout, brings that score down to 90. The design option 3A, the modified T with signals, 99. And option 3B, standard T with traffic signals, is 105. And these scores have been brought about by the combination of the exposure, the likelihood score for each of them, and the severity score for each of them. So what we can tell from this immediately, and some people like to do an overall graph first, is that every one of these aligns better with safe system principles than the existing conditions. But this one, the roundabout in this circumstance, has the best alignment with safe system principles. Then the modified T, then the normal T. But it's not good enough to just stop there. You want to go to this graph as well and get some details on that. And this is what I showed you at the start, so it's no doubt familiar to you and hopefully makes more sense now. We see that the roundabout's helping out in runoff road, actually. That'll be heavily due to the severity and the lower speeds, no doubt, but the curve of the roundabout will have probably bumped it up a little bit. It's going to help out in head-ons. It's going to significantly help out in intersections. But here we've got cyclists not doing as well. And so that's definitely something you'd be noting. And you can see how these scores have been generated for each of these. And so what we do then in a safe system assessment is to say, right, what can we do to bring all of these scores down? Obviously, the existing conditions will stay as it is. But what could we do if they decide, no, actually, we're going to do this modified T signalized one? Well, hopefully they're taking this into account when choosing the intersection form. But if they say, well, we don't have the budget for the roundabout, there's some native vegetation on the side, there's a cultural heritage issue there, we'll never be able to get this roundabout in, we have to signalize this. You go, okay, well, here are some ideas if you're going to signalize it to get it even better alignment with safe system principles. Now, before I jump into that for a little bit more explanation, I'll pause again, Kathy, and I'll see if anybody wants clarification on where we're at so far.
Thanks, Ken. Okay, so looking at option 1.
Yep.
Sorry, just a calculation check here. Can you tell me, how did you calculate 64 in every column when it's 4, it's not 4 plus 4 plus 4, is it? Is it 4 times 4 times 4?
Correct.
Good one, thank you.
I hope that works out to 64, otherwise a lot of us have been doing things wrong for a long time.
Oh, good, I think we've got that. Turbo roundabout, drops mic, walks off stage. Just another little comment there. We should add that into your webinar, Ken.
We should get a little emoji thing, a GIF, dropping the microphone, walking off stage, or dropping the microphone and going through a turbo roundabout.
Nice. Okay, and the traffic count website I loaded isn't working, so that's good. I'll fix that shortly. Thank you. Any other questions? No, we're good. But keep your comments and questions coming through. It's great. Oh, hold on. When is it a reasonable improvement score to justify, say, a $3 million plus investment?
Wow, really good question. And you're starting to get into this sort of idea of risk reduction ratio of cost to risk reduction. So almost like benefit cost ratio there. And I don't have direct answer for that, and you've got to work that out on each project, or how you go about thinking about these sort of things. But what we do like to do as safe system assessors is be a bit sympathetic to things like budget constraints and different issues, and try to look for innovative solutions or ways to make us be able to get scores significantly down at some lower costs. And we provide some options often in there. So we say, well, you'd actually get the best reduction in your scores if you did these sorts of things. But if you can't afford those sorts of things, or you get your next best with these sort of things, and then you get a little bit of score reduction with these sort of things. And then, you know, hopefully they'll go for the ones that give us the biggest reduction, but they might have to pick some of the lesser ones. And one of the ways we do try to help with that choice is to categorize any ideas, any recommendations for treatments into primary or supporting. So a primary treatment are road planning, design and management considerations that virtually eliminate the potential for fatal or serious injury crash occurring associated with foreseeable crash types. Safe system supporting treatments are road planning, design and management considerations that improve the overall level of safety associated with foreseeable crash type, but are not expected to virtually eliminate the potential for death and serious injury occurring. And it doesn't change the ability for a primary treatment to go in. So what we see there is that supporting treatments are often our signs, our line marking, our sealed shoulders, wide center lines, all these sorts of features. We know how to improve the situation, but we know that some people still, if their lanes still go across that wide center line, still have head-on crashes. The audio tactile line marking does a great job. However, it doesn't virtually eliminate people dying and being seriously injured. It just reduces the number. What we see for these primary treatments are things like single lane roundabouts for the intersection type crashes between passenger vehicles being primary. We see raised safety platforms, wire road barrier systems for run-off road crashes for passenger vehicles, and those sorts of features. We also have the ability and are encouraged within a safe system assessment to suggest things outside of the infrastructure, just the pouring of concrete. You could be saying, well, there's a pub on this corner. Can we work with the pub for to do some sort of initiatives to try to minimise drink drivers, or how people, where they have their taxi ranks maybe. There's a school, can we work with them on information about how the children should use this new intersection that's being built down the road? And it could be anything like that. And in these infrastructure projects, that's a wonderful sort of way for us to holistically think about the system. And it may be then that some of these infrastructure projects, you're going over and you're talking to the behavioural road safety team, the community road safety group, and you're saying, well, we're upgrading these intersections. Are there, what can you tell us about this area? What could be injected into this project? And it's been, wonderful wins in road safety for anyone just starting those conversations. That's been a massive win. Often people talking to the police about, what do they want to do with enforcement? What have they been doing? What can they tell us about that? They're saying, well, we're building these upgrades. Are there things we can do? And we get that, rich mix of the holistic system rather than just the specific infrastructure. So those can go in there as recommendations as well. And in order to help that, and also to inform your scoring of the matrix, within a safe system assessment, there are these prompt questions. Now, they're not every question you might want to ask, but they certainly cover a raft of things outside of the infrastructure itself, or that interacts with the infrastructure, but it's not directly what we usually do. And in a safe system assessment, at least a full safe system assessment, you are asked to write qualitative answers to each of these questions. You're not quantifying these. You're not putting numbers to them. You're just writing answers. If you want to change numbers as a result, you do that back in the matrix. But the questions here are into the categories of road user, vehicle, post-crash care, and they're really trying to cover off all rafts of scenarios and scales of projects, so they're quite broad. So are road users likely to be alert and compliant, and are there factors that might influence this? What are the expected compliance and enforcement levels? Alcohol, drugs, speed, road rules, driving hours. What is the likelihood of driver fatigue? Can enforcement activities be conducted safely? Are there special road users, entertainment precinct, elderly, children, on-road activities, motorcycle route, distraction by environmental factors, big billboards or tourism style things, and what's the risk-taking behaviour? So you're making notes under this, and you might be wanting to talk to people who know the area well, talk to the police, talk to the community road safety people, talk to others, get this information, get a bit of an idea of this. And it may just spark something in your mind that you could consider adding as a recommendation as part of this project. Or it could be something that you go, wow, okay, as I talked about before, okay, they've told me, wow, there's actually a lot of risk-taking behaviour in this area, and I'm going to bump up the scores of likelihood of crashes and severity of crashes a little bit as a result of knowing that. And maybe one of the recommendations is associated with, talking to the police about whether some more enforcement could be done, or if the alterations in the infrastructure could be done such that maybe it reduces some of this risk-taking behaviour. Hopefully not just moving it onto another location, but trying to, or at least make things a bit safer. Vehicles. What level of alignment is there with the ideals of safer vehicles? Now that's usually at a community level question. So if you're doing a safe system assessment of a whole community or a mining site or something like that, and you look at the fleet and you ask, how safe are the vehicles that they're driving around? Do they all have pedestrian protection and those sorts of things? So often in just the infrastructure project investigation, it's assessment, it's not, you don't put too much information in here. You may, if particularly know it's an area that has a lot of older, unsafer vehicles, it might factor in a little bit into your severity score maybe, but it might not. It might not be enough to get you a change there. Are there factors that might attract a large number of unsafe vehicles? Is the percentage of heavy vehicles too high for the proposed or existing road design? Is the route used by recreational motorcyclists? Are there resources in the area to detect non-roadworthy, overloaded or unregistered vehicles and thus remove them from the network? Can enforcement be conducted, undertaken safely? And has vehicle breakdown been catered for? So for me, that's probably been the most important, or the question that's generated the most change as a result of these ones. But that's because when you roll out a big plot and you're going to plan for a big project and big changes, and you have the police and you say, hey, how's this going to impact on enforcement, and are there changes we can make to make enforcement better? And they just get so excited about the idea that they would be able to have some input at this early stage of a big project. And we've seen some wonderful outcomes in terms of just the configuration of the project to not only just cater for enforcement, but actually help with their ability to maybe set up the booze bus or park the speed camera vehicle, or to put a number plate recognition vehicle in an area that's purpose built for it, in a sense, and can be protecting of their road, of their workers, and make it just a wonderful scene. And when you're talking big projects, these are minuscule costs in little tweaks of design and planning that can give wonderful holistic road safety outcomes. Then you want to post-crash care. I know you've got a question for me, Kathy. I'll just finish with post-crash care and then I'll come back and answer for any of those. Are there issues that might influence safe and efficient post-crash care in the event of a severe injury, congestion, stopping access space? Do emergency and medical services operate as safely and efficiently as possible? And that's been ones where we've seen things like helicopter landing pads suggested because the area is so remote up in the mountains that you know, the emergency service is taking forever to get to injured motorcyclists or passengers of vehicles, and that this is sort of helping to get within those quick time frames of response, those sort of golden hours and those sorts of things. Our road users emergency response teams protected during the event of a crash, and our drivers provided correct information to address travel speeds on the approach and adjacent to an incident. Some of these are very sort of motorway style questions, or major freeway style questions, but they're asked and you think about them. That's a good thing. Is there reliable information via radio VMS? Is there provision for e-safety safety systems based on modern information communication technology, cooperative ITS, and those sorts of things? This is a bit of a question of the future, and this is going to build and build in our safe system assessments, and asking about your comm systems, your ITS infrastructure, your ability for the cars in the future to read the road and understand what's going on. This is an emerging area, and we're continuing to build knowledge in this. There's been a couple of recent releases of really good reports out of Europe called Roads That Cars Can Read. And so I suggest you can have a look at those. But again, you're just dot pointing ideas and thoughts around these that may help you either alter the scores in the matrix or come up with recommendations. And the recommendations could even be things like get a ITS future vehicles expert to review the design. It's a multi-billion-dollar project. Of course, that's a very logical thing to be doing. They're probably doing it anyway, but it might be something to think about. So, Kathy, questions?
Thank you, Ken. Okay, what about risks that you can't control, like glare, fog, or a road that is aligned as such that the sun is in your eyes? Is there any point in listing these as negative factors that don't have any mitigating controls?
Yes, there is. So you may not know of that, but somebody receiving the report might think of something. But you definitely list these in here, and they may stay just as dot points from the existing conditions, and in each design it still exists. But we know that there are sort of some things that may trigger something in somebody's mind as a way to bring that score down a little bit. I mean, certainly we know that there's things you can do associated with backing boards, big backing boards on different critical signs. You can do larger backing boards on signals to do those sorts of things. So, they become a bit more, able to see in some of these times. And what I always say is that we're continuing to innovate. And if they're dot pointed there, and people might come up with ideas and innovate. So yes, list them. Just because we don't have a solution for it doesn't mean it's not a risk factor and something that should be pointed out. Yeah, I think absolutely.
Thank you. Lance has commented there's an Austroads road stereotype guideline that has method to evaluate different options from a dollar point of view. You familiar with that one, Ken?
I am. Yeah. So the idea of this sort of network risk assessment methodology is something that's sort of moved forward. And in fact, the most recent release of the Austroads Guide to Road Design Part 6 has some really good risk reduction curves for run-off road, and then you could equate those to dollars and the like. It's kind of relevant in a safe system assessment, but it's kind of not as well. I think they're those sort of things that a project manager and designer should be really taking on. The assessment itself can be fairly free and open to make big picture recommendations and some other ones, and then the project manager sort of can make some choices and maybe continue the conversation with the assessor to try and say, well, what sort of score reduction do you think I'd get if I did these sorts of things? And you can have that conversation, and it may be based on some of that good recent Austroads stuff that's been coming
out. Just a comment here on different things happening in different areas. So near the University of Adelaide, of Adelaide, there was some old vehicles being driven by cash poor students. So that's probably one of the things that you'd pop into this.
Yes, so you might sort of have that as part of your assessment. You go, okay, well, this area, there's a lot of bad vehicles with bad safety features or the like. And we've seen this more prevalent, I suppose. It'd be an interesting one with the uni areas and those sorts of things. But the sort of some of the remote communities that safe system assessments have been done on have sort of identified some of the vehicle fleets being enough that you actually start to alter your safe system assessment scores for severity outcomes and things, because you know that if these crashes happen, it will really into some pretty severe outcomes and the like. So the other thing I do want to point out, I'm going to jump back a bit. Yeah. This is a really exciting part of a safe system assessment for me, is that you only have that 0.5 to play with. And we encourage you not even to go to 0.5, just to stay at whole numbers. Now, the reason this is really exciting for me is because you get people in projects who are doing things and they say, well, we put a warning sign up for that intersection. And you go, okay, that's good. And that's going to reduce the likelihood a bit. So, you might say, well, okay, the likelihood of intersection crashes has gone from a 2.5 down to a 2 because you've put a warning sign. They go, but we're going to put another warning sign on the other side of the road. We're doubling up the warning sign. So this is now a safe system project. That's what they're trying to say. And you say, well, I'm not actually, that's not enough to warrant that going any further down. Or, it goes down a little bit, but not enough for a 0.5 change. And then I say, oh, okay, but we're going to do some surface improvements. And you go, well, still, we're not actually at this, point to get enough of a change there. So what it is actually forcing is us to look for bigger picture, more substantial step change alterations that can get us that actual reduction in these scores. So yeah, it almost like pushes us to stop tweaking around the edges and start to actually do some fundamental things that will reduce the risk significantly. So I might introduce the task here. Actually, I'll start with this. This is a safe system assessment report in its full thing would identify the type of assessment that's happening between a full and a rapid. And next module, I'm going to take you through the details of those differences. Same process, just slightly different things. It's meant to be a little bit quicker to do the rapid. From its name, you'd guess that. But it's not a major amount different in that. List the members of the assessment team, meetings and site inspections, when they were undertaken, who was there, description of the process, project background and the context, which you're getting from those prompt questions. Then you do the matrix and scores and commentary. And then design options. So you do it for existing conditions and then all of your design options, you do a matrix. Commentary on the other safe system components or elements. Some people call them pillars. I talk about them as elements, interacting elements. And then any suggested treatments, and then we categorize those as well. Now, what we've done to make your life easy and hopefully get a bit of consistency is provided you with an example of a completed safe system assessment report. So you could look at that, how's it structured, what's in there. And then for the assignment, what we've done is we've grabbed, in this case, the Victorian government template on safe system assessments, given you that, and said, and then what we did is highlighted in yellow the bits that you need to fill out. So we're not going to get you to write everything out, just the bits that we want you to fill out. And I'm going to jump to that Word document in a second and walk you through that step by step. got to really stress that the site visit is part of this. It's an important part of it, and it helps you to gather a picture and an understanding of the environment, how it's being used, little bits and pieces that you'll never pick up from a street view, and the like. And so we do want you to go to site, and we really need you to be safe out there. So wear your high-vis vest. Really stay off the road for the majority. You don't need to be out there with the measuring tape, getting lane widths or putting your head down to look at the crossfall and the like. Don't be a hazard. So if it is in a sort of urban area, don't be pushing road, standing there in a group and making road users have to walk on the road to get around you, or these sorts of things. Park safely. Don't block sight lines out of intersections. Don't park in spots that again make maybe cyclists go into traffic lanes and these sorts of things. Park down some of the side roads away, and just be careful out there. We've prepared a safe work method statement for you that you have to acknowledge within the Schoology quiz that you have had a look at it. It's very common sense stuff and very much something that'll all be part of your organisational policies. But you don't go out on the site if you're intoxicated, and don't drive to a site intoxicated, and wear your high-vis vest and all of those sorts of things. So we've looked at each of the sites, and it can be done at very, very low risk, as long as you park safely away and don't be doing anything crazy out there. That's probably all I need. Oh, the other one, I suppose, is as happens when you wander out onto a site with a high-vis vest on and a clipboard or a plan in hand, there's a chance the community will be coming out to find out what's going on, or probably tell you all their issues and these sorts of things, as many of you are very familiar with. And simply say you're on a training exercise, and don't show them the plans, because there's either these are plans that have been produced specifically for the training purposes, or that they are existing plans that may or may not be ever built, or the like. And it's not our job to be doing consultation with the community. This is a training exercise, so please, please don't. In a real safe system assessment, I'll sometimes just have a chat with the local cafe, sit down and have a coffee and just have a chat. Oh yeah, what do you know about the intersection? Oh, where do people come from? You seen any incidents? Yeah, what are your thoughts? Yeah, you get a nice, good, rich bit of information sometimes that way. But for our training exercise, don't do any of that. And in real, in a real safe system assessment, be understand what your client would want. Don't be doing that, obviously, if you're doing a sensitive project or the like, especially don't, yeah. Anyway, you know what you're doing out there. But I just don't want anybody ringing up the local council and saying, why are you building this? And the council will be like, I don't know, never heard of this.
Ken, sorry, this is an intense session, this one. Do you think we could give everyone just a 4-minute break according to my clock at this stage? Would that be all right? Just a bit of a stretch break, refresh your drinks, that sort of thing, and we'll tune back in. You won't miss any Wallies or anything like that at 11:35. Oh, that just became a 3-minute break now. So
good. I'll find my water. Good
yes.
call.
So we'll be back on again 11. Well, we won't really leave, but 11:35. So toilet break, drink break, all those sorts of things. All right, hopefully everyone's ready to go. 25 minutes to go, so.
Yeah, and we may not need all of that, but I do want to give a bit more detail on the assignment, the task at hand. And we do encourage any questions of clarification, because this is when we're handing it over to you to actually do one of these assessments. So what I'm going to do, Kathy, if there aren't any questions that have popped up exactly yet, actually, sorry, I'm going to, no, let me stop that. My bad. Give me a second here. I'm just finding the Word document that we've provided in which module folder?
Module 5.
Module 5 folder. Okay.
Module 5, yeah.
So you'll find in module 5 folder a Word document. And this is the Word document. I assume you can see that, Kathy?
Mm-hmm.
Good. And you'll see there, it's got this big stamp over it, complete only the highlighted sections. And so it is using the Victorian template. There is no New South Wales template at this stage. And so people are using this. The Victorian government has said that here's a template, feel free to rebrand it as you want, use it as you want, just to try to get consistency. So, you know, if you want to use these in the future, you're welcome to do so and rebrand them as you like. Complete the highlighted sections only. Okay, so executive summary is crossed out. You don't need to spend time writing up executive summaries and the like. You don't need to update the table of contents. You don't need to update the figures and tables. Obviously, if you were doing a full, like an actual safe system assessment, you would update all of that. We don't need any of this. We just want you to put your name in there. Now, if you happen to decide to do it in a group, which we're okay with, if you've got the same site, obviously, you put the names of the team that was involved in this. And we do want, if you're going to do it as a team, everybody to play a part and work it through, not just hand it over to one person to do. We won't get you to do any of this filling out of any things. You're not going to get a whole lot of project context, descriptions, backgrounds, or any of that for the purposes of our training exercise. But again, in a real one, you'd fill out lots of information here to explain the project. What we do want is a short summary of what is being planned as the infrastructure upgrade. And then we want you to put in there a bit of a summary of the assessment, the outcomes of the assessment. We want to see the scores, the overall total scores out of 448. And we want you to create a graph. So you're going to replace this graph with the one you are going to make yourself in Excel or whatever graphing software you would like to use. You're going to have to plug your own numbers in there, produce it, paste it in here. So you insert the existing conditions matrix. So you've got this, you're going to fill it out. You're going to put lots of dot points under each of these. Put scores in. You're going to do this one times this one times this one equals this one. And then you're going to add this one plus 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 this one to your total score. Once you've completed that and filled it all out, you're going to copy this and you're going to create a new one there. And maybe you're going to create a, you're going to title this, of course I'm having trouble here. And then you're going to adjust that accordingly. And so you'll have all this stuff filled out, and then you will go through and you'll highlight, you know, a dot point you have there, which is, I don't know, what are we going to say? Factors that increase life. So you've got no sealed shoulders from the existing conditions, and then you might go, right, I'm gonna cross that out. Where's all my stuff gone? Taking that down. So then I'm just going to cross that out. Or, you know, if it was new, you might not cross it out and you'd make it red. So you're going to go through and you're going to do that. So your first thing is fill all this out, populate this existing one, populate this one, create your graphs, fill it out. Then you're going to come up with some treatment ideas. And this is for the design. So they've planned this. You can say, well, I suggest you do you know, a roundabout, or you know, raised crossing points on the approach, or whatever you've decided. And you categorize those into primary or supporting. Now, this can be a bit of a challenging thing to do. So what the Austroad Safe System Assessment Framework has done is for each crash type listed a whole lot of possible treatments and then categorized them into primary or supporting. So you're able to have a look at that. And so that's one of the things that we're noticing as I train up lots of people in Australia and New Zealand on safe system assessments, is that people aren't categorizing them right. And that's because they're not looking at that Austro's document when they come up with their idea to where it might fit. Don't worry about writing a conclusion. And then we want you to add a photo of yourself or your team at the site. So we know you actually went there, and that gives us assurance that you've been through the process comprehensively, you understand it, and we can give you a certificate, assuming you get your 80% mark plus on this. That means that we have confidence you know the process and you've been through it all. So a photo of you out there on the site in one way or another. You could put some other site photos if you wanted, but you don't need to. So we've tried to trim it down just so you're doing the meat of this and you can show that you understand the process. So that's the Word document. Any other questions coming at this stage, Kathy?
Not yet, but now is a good time to ask questions on this. Now I have made it due on the 23rd of December, so that's awfully late into the year. So I guess the recommendation would be to get out, if possible, and do your site visit in the next week before our last session, which is next Thursday. And that way you can come back with any questions as well in our next session, which would be a great idea.
23rd.
Yeah, Ken, you said you wanted to do some marking on Christmas Eve.
Yes.
Christmas Day activity.
Yes.
With your family. Can you tell us the name of the guide for the primary and supporting treatments again, please?
Yes, it's Austro's Safe System Assessment Framework, and I'm going to actually pop it up on the screen now and show you where that is, because it is a good one. It's important. Of course, I'm just trying to grab it now, and it's drawing it down from the cloud, which needs to happen these days, doesn't it? Yeah, get those as assignments in as soon as you get. The quicker you get them in, the quicker they'll be marked, and quicker you'll get your certificate and your prizes and your completion. Obviously, we don't issue any certificates or the like until we are satisfied and you've got those sort of pass marks. Now, what's going on here? Okay, so the document that I keep referring to is this one. We have put a copy into your memory stick onto Schoology, or you can download it from the Austro's website at any point. It is the Safe System Assessment Framework. It's got this this is the cover of it. And what we find there is treatment hierarchy and selection, page 14. I was way off on my memory of that. So treatment hierarchy and selection. And you see these tables. So you see it's categorized runoff road to the left or the right. And we can see here option primary treatment, supporting treatment, supporting treatment. Now there's these two categories of supporting treatment. Don't get too fussed with that. Just think of those as supporting treatments. And then they've got these other considerations. They might be speed enforcement, rest areas, and like runoff road. Head on, intersection, other, pedestrian, cyclists, motorcyclists, and they just happen to be the same as our columns in the matrix in terms of the crashes. So this all sort of pieces together really nicely. So they will help you in terms of primary or supporting, and they actually even help you a little bit in terms of exposure, likelihood, or severity if you want to calibrate that thinking as well. Good little reference there. And for those of you who are really trying to achieve those super high marks, it's a pretty easy way to do that. You just make sure you've got that open with you as you're filling out the matrix and looking at it and referring back. We've also given you a completed safe system assessment in that folder. So there's another good way to have a look at how it's been done, make sure things line up.
Okay, I think we've bombarded people with all of that. So they don't have any questions just yet, but
they're chomping at the bit to get out on site, Kathy. They've got high-vis vest on, clipboard ready. Just wait just to finish so they can run out the door and get to their intersection.
Okay, all right then, in that case. Now, you said the New Zealanders have a good way of saying this, and Paris said this at the start of the session, and I've saved it for the end of the session. It says, hope for the best, plan for the worst. But what's the New Zealand, how do the New Zealanders say it, Ken?
Really testing me, aren't you? It is along those same lines. Give me a second. I'll remember the exact wording, or find the exact wording. Probably is a more accurate description here. It is that they say we promote good choices but plan for mistakes.
Yeah,
so it's the same idea, but probably more from a road authority perspective. So promoting, encouraging, trying to basically stop people crashing and make good choices on all their things, but plan for mistakes. Hope for the best, plan for the worst, but actually encourage the best and try to do things to make the best happen. But yeah, but thank you. Yeah, that's a good one.
So Chantal's just written saying there's a cartoon character that this moustache of Ken's reminds me of. I need to find it. I'll ask my 7-year-old. Needs to be his profile pic.
Is it like Yosemite Sam or something?
I think it might be. Anyway, but I do have access to your LinkedIn account. So stay tuned, people. If you see an update to Ken's LinkedIn account, then you know what's happened there, and I might not see you next week. So, but we will let you go early, I think, before I get into any trouble here.
Yeah, we've sort of gone off the topic of safe system assessments. But what I do want, though, on that is if you are having any trouble with this at all, so if you're not quite clear on it, or you don't understand, or you're feeling really nervous or uncomfortable about this idea of trying to do this, get in contact with us. Shoot an email through to Kathy or myself. We'll have a little one-on-one Zoom session with you, or we'll have a phone chat, or we'll send you some more examples, or even FaceTime in when you are out there on site in a nice, safe location, and you can show us stuff and we can chat about it. Because we're here to help you get your head around this and make sure you can do it. So it doesn't, we're not throwing you out in the deep end. Some of you will happily have a go at it and then get feedback when we mark it. And remember, you can submit up to 3 times if you want. So if you put it in and you go, oh, okay, I didn't really get that bit, I'm going to alter that, change it around, and you can resubmit it and we'll remark it. So don't get too stressed out. Lots of support for you available. Just get in contact with Kathy or myself and we'll make that happen.
Good note to end on, Ken. And remember, you can do it with your colleagues from the same office or nearby. So small groups is good. Maybe three people would be great. And just make sure you put everyone's name on your report when you submit it. Good. I think we'll wrap it up. Have a good week, everyone. Thanks.
Good luck.
See ya. Bye.
Bye.